Hello, everybody. I'm David Canigliaro. I'm the mill product line manager for CNC Software. I appreciate everyone taking the time to spend some time here this morning talking about how to use stock when you're creating finishing toolpaths. Traditionally, we use stock when we think of stock as an aid when we're machining, when we're roughing our parts. So we reference a stock model, we rest rough, and then we update it and we reference it again, and we continue to rough a part out with smaller tooling and getting into tighter areas. But the webinar today, we want to talk about, well, what else can Mastercam do with stock? And we want to focus on finishing and semi-finishing. So I've got a few examples to run through and just throw some concepts out there. So the first concept is, so I roughed, I created a stock model, and for this example, and a lot of my examples, I'm keeping them simple. I'm just in this pocket, okay, and we're pretending like we ran this water line to kind of semi it down a bit more, and then here's my stock. And now what I'd like to do is clean these corner areas out a little bit more. And I can go to my waterline toolpath, which is a finishing toolpath, and I could reference stock, but I get a result like this, which is very noisy because this waterline toolpath, it sees some of the, some of the cusps on the wall from the roughing. It's not very clean. It was just rough. So the software is very accurate, and it says these are all the areas where this waterline toolpath is touching this stock. I'm like, well, that's not what I want, right? So I could get a result like this if I understand my settings. So what I did for the first example was we turned the stock page on and we reference a stock model. So the waterline calculates a complete waterline, and then it trims all the passes that are in air compared to that stock model. It only keeps passes that are touching stock. And that was the first result. But it was set in the adjustments to remaining stock section to use as computed. That's a very literal interpretation of the stock model mesh. Now the stock model meshes, they're not always pure and clean, especially from a roughing toolpath. So we need to relax how sensitive this waterline toolpath is to stock. So we could say, I want to ignore small cusps, small pieces of material. Then I said, anything that's a quarter of I'm in metric, right, millimeters. So anything that's 0.25 millimeters or less, I'm not interested in that material. I want any significant material, greater than a quarter of a millimeter. And that filter right there is what took me from this result to this result. So all these specks of stock that this was hitting were all less than a quarter of a millimeter. And I got this result. So that's what I wanted. And then I noticed that, well, I don't want this pass on the bottom, right? So I try to limit that. So the next toolpath, maybe you're thinking, okay, that's a shallow pass. As a Mastercam user, we know we can come in here and, well, I'll just say machine everything from maybe 10 degrees to 90 to get rid of that pass. And I update it, and it comes back, it's like, oh man, what's going on? It didn't do it. Well, the reality is that is a steep pass against this wall down here. So that's not shallow, it's steep. It's deceiving, right? It's steep against this wall. But as a human, we saw it and said, oh, that's shallow. No, it's steep against this wall. So then I said, well, let me go in and I can give it a Z limit, and maybe don't go lower than this, right? And I always set myself back when things don't work. Change one thing at a time, right? And I limit it. Like, oh, okay, cool. That's, I can live with that. I'm happy with that. And then I decide, well, how accurate was this? So I turn my stock on and I go to analyze toolpath. I love to use this function, and I'm going to pop my tool right on the end of that pass, and I can see where it's engaging there, right? And there's the step down and then in. Like, man, I wish I could I wish I could overlap this a little bit here and maybe a little bit here. And that's where this ends. That's where I'm stuck and I cannot do that. There's no way with settings in here to tell it like to extend and go further out. I can't do that. Plus, I had to mess around with that skip with the adjustment to small cusps. I got to get that number right. And in this case, I had to do a limit and all that jazz. So if we just skip down to here, you know, here's a different result, a lot cleaner and a lot more straightforward. What I did was I created a stock model of the four corners, you see? And to do that, I went in and I had to convert a couple of these solid faces to surfaces. Let me turn this off for you. Surfaces, see? I can then create a stock model from model data, select those surfaces, and then I give them I puffed them up a 0.5 millimeter to give them a volume. I created those four shapes. Now, unfortunately, in Mastercam 2021, I can't just go and simply select those four solid faces. I can only select an entire solid or surfaces or mesh. But you'll be happy to hear that in Mastercam 2022, I do not have to create these surfaces. It does support the selection of solid faces. So that's a step you won't have to worry about in the next release. So I create this stock model where I'm interested in machining. And I just create a waterline, toolpath, and I reference that stock model, you know, as computed. I'm not worried about all that noise anymore. But here's the best part. Remember I said, well, I'd like to extend these, right? So let's take a look at first how accurate this was. And I put my tool here. You can see a much smaller piece of material up here. And then as I come down, see, as it gets into cut right here, the blue, it's not in material yet until about here. So it already is a little bit better than the other example. If you recall, the other example, as soon as it got to blue, and even some of this transition was even in stock, right? So I'm already in a better position here. And if I flip between this toolpath and this toolpath, you can see this is shorter, this is a little longer, shorter, longer. Here's the beauty. I want more extension. So it's a great thing. I just go into here and I say, you know, give me some more puff. Puff it out 1 millimeter. It goes dirty. I regenerate it. I regenerate the water line. And that easy, I've pushed the toolpath out even further. So now you've got this original and that. Original and that, right? And you know, the first, you know, sometimes your first line of defense as a programmer is, you know, if you understand how to do that, great. But maybe you don't know how to get rid of this, so you start drawing boundaries around areas. But it really needs to be a very accurate boundary to clip this. If you start to think about stock models as volumetric regions to bound your finishing and semi-finishing toolpaths to, you can open yourself up to a whole new world of putting motion where you want it and easily manipulate. I want that a little longer. Okay, so I'll go with a big number, 3 millimeters. Shade it up here for you. I'll update just the stock. And look, it offsets. Now that looks ugly and it's up in the air, but remember, this has no influence on how the waterline calculates. It's just the volume of tool contact that this toolpath is allowed to run in. And that easily, I extended it, right? If you turn this on and I go to Analyze Toolpath, you can see as I put the tool right here, it's even got a little bit of a buffer zone for you, you know. So it's a very simple way to isolate where you want to put material. And in that moment, you can make some adjustments. So that's the concept, in this case, of how to use stock in finishing toolpaths. I have another example. In fact, it's easier to open it this way. Love the drag and drop. Another scenario. exact same thing. I have a toolpath, I generated a pencil. Now I know this pencil is going to find a little bit here, a little bit there because of the size of my ball end mill. What I'm interested in are these two features. But what I'm not interested in is this here. It's, it's pencil tracing here. I just want these this outside pass and this outside pass that go around nice and clean. But I can't distill that, and then these are here. And it's very hard to try to draw a boundary to isolate this because this is in the way, this pass. So you would think, well, okay, steep, shallow. Well, no, because this is shallow and this is steep. So I can't do steep. I'm really just stuck. I don't want that. I can't, there's no check surface support in pencil or avoidance. So what do I do? So to get this result is very simple. There it is. Simple, simple, simple. I convert my fillets I'm interested in to surfaces in this release, and I make those into a stock model. Again, in Mastercam 2022, I can just pick faces. So I created this stock model with those fillets. And I asked this pencil to only keep motion that was touching the stock model. See? And it's not that the center of tool has to be, it's tool contact. And that's the simple way to control this. And again, you could use it to your advantage, right? So here's another stock. Maybe I just wanted to clean up down here for whatever reason. Please don't question the parts I'm using and why do you want to put motion there. We're talking conceptual today, right? But what if you just wanted to run it there? It's so easy. You just go into the pencil and you pop to the other stock model and you say go. And all that easy, I've got some pencil passes where I want them, exactly where I want them. There they are, nice and clean, put them right where I wanted them, and I was able to control it. Now I could have done that with a boundary, you would think, but can I? Because remember, there was a pass here originally. So the boundary doesn't always help you because this would have been here still. So I use it a lot to control pencil toolpaths and lace them really exactly where you want them. And I always like to throw this one in here too. This, we'll go back to this, we'll go back to the original result. And I always like to point out, don't forget about, for the multi-axis users out there, you got the tilt attached to all these 3D toolpaths. And then we tried with this taper tool, but to be safe, but and I purposely made this short stubby tool. But it's a scary thing with the holder here. I mean, we are actually violating, right? And of course, you would have proper tooling and proper hangout if you were to run this on a 3-axis machine. But don't forget about our tilt technology, and I'll show that with some vectors of this toolpath here. So there's multi-axis, and you can see it go back to vertical. And that was just simply taking the pencil, referencing the stock, and telling it to do some holder checking and tilt to avoid. And then we got that really nice, simple, graceful, safe result. And there you go. If we're fortunate enough to have equipment capable of doing this. And there you go. So that's another example of using stock models to isolate where you want to put material. Okay, so that's one concept there. I use 2 examples to show it. You can let your mind run wild with that. There's all sorts of things you can do with this concept. You can draw, you could literally create anything you want here, boom, this is going to be my stock model shape. And I can write a toolpath on this and say, only keep what's touching this. There's all sorts of ways to use the concept. Next concept, different concept, right? So those 2 examples are one concept. Here's a different concept. Something else we can do with stock when we're finishing. Here's a part, and I'm interested in roughing and semiing and finishing, of course. So there's a rough, there's a stock model, and I want you to take note of this deep pocket here feature, and you can see my rough tool did not get in there, right? So I would be crazy to run this water line right now if I didn't want that contact. Now I'm stepping down small, but maybe I still don't want that contact. That's a lot of contact into this material. I am stepping down, but maybe I still don't want to do that, okay? But I need to rest rough, and I don't want to rest rough against this right now because I have a feeling it's going to identify all these ledges for rest roughing. But all I'm really interested in for rest roughing are, you know, these corner areas here and, you know, these corners here. I'm not interested in this when I rest rough. So I'd be messing around in my rest rough toolpath with that ignore cusp function to get it to ignore these cusps and just go in the corners. What I really want to do is I want to do a semi-finished pass before I do my rest rough. And a lot of people do that, but it's not always safe to do that because of heavy stock sometimes. I'm going to show you how I can create a waterline toolpath on this part right now and not violate this stock by more than a defined depth. So it's going to come around this model, and notice they didn't go all the way in. Here's a normal waterline tracing this part data. Here it is with stock awareness. It traced and just dug into the stock a little bit. And that let me update my stock model to this. Now notice how clean this is now, right? So would you rather rest rough against this or against this? And here's the rest rough. Look how very clean rest rough, because I semi'd before, right? You know, this rough toolpath left 20 thou stock. I'm in an inch part now. We're in imperial. That rest rough that I wrote, I shaved a little bit off as I went, right? Still has 5. But the key was the stock page. I didn't use trim to stock. That's what we had just talked about previously. I used max stock engagement. I pointed to the stock model named rough, which was this one. And I said, don't dig into it by more than 0.075. Accept. And you can see that these were the spots. And even right here, you can see if I turn this on, and maybe I take my analysis. I love using Analyze Toolpath, and let's get it in somewhere like here on this pass, or this pass here, because that's the top. You can see it's digging into stock, but that's as deep as it went. As deep as it went. It's not going to go any deeper than 0.075. This is not a perfect science all around, but this was developed to protect small tooling at times. It's a very niche function. It's not something you use all the time, of course, but if you understand what it does, you could exploit it and utilize it. In this case, I'm not using it to protect small tooling. I'm just using it so I can, you know, not go into that corner. I'd rather my roughing go in there, because, you know, this tool might not be big enough. I mean, this motion might be safe because I'm stepping down, but when it gets in and back around, it could leave an island standing here if the tool wasn't wide enough. And I don't know if this tool, this tool, you know, would leave an island at some point, and then it's going to go, when it runs across, it's going to hit. It's just not friendly. The step down is what's going to save me, but I could leave material. I don't want to deal with all that. I'd rather it just say, hey, you know, when you get to that stock, just kind of follow it along, only go into it so far, and I'll deal with this later. And I was left with this shape. So if you watch right here, you'll see this is way out here because I left 20 thou roughing. And then this one, I'm sorry, we'll go back here. And then this one left 5 thou and was allowed to dig in by 75. So, you know, of course it went in a little more, but it was safe and controlled. right? That's what max stock engagement does. Then it afforded me a much friendlier stock shape for this rest rough to look at. It didn't see any material here. It doesn't see cusps here. It just said, oh, that's the meat right there. That's the thick meat, and it hit it. And then there's my updated stock model, and now I'm ready to go and continue on my way with semi-finishing and finishing. So this max stock engagement is another way to use stock when you're finishing and semi-finishing. It can really help with small tooling when you're concerned about a few areas, but you just wish you could write the toolpath anyway, and you know you're going to clean that small area. This helps in scenarios like that. You don't have to deal with that cleanup area right away. You can first just run the whole toolpath, protect it with max stock engagement, and then assess what material is there, because you will have milled a little bit of it away in that moment instead of spending time cleaning it all up beforehand. So it's something to file away. It's a concept, and you know it's on the stock page. It's on. Oh, I'm sorry. It's on the stock page in the 3D HST. Not all the toolpaths support it. For example, like the equal scallop, you know, it's going to be grayed out for I think just maybe hybrid and equal scallop, I believe. And no, it's awake for hybrid. So you know, we slowly enable it for everything, you know, over the releases. But it's there for waterline and scallop and raster and pencil, and fantastic functionality. Max stock engagement. All right, so let's wrap this up with two more concepts, and we'll kind of bank on those two as well. So this is more of an application exercise. Let me wrap my head around this real quick again. So we're going to no. We're going to keep this simple, as simple as I can. Here's a blank piece of material. Pretend it was roughed. I just created a solid and got some stock. This is just an example. I ripped this hybrid across that just to get myself my semi model. I didn't want to spend time roughing it. This is a webinar. So this is where we are right now. This big 1/2 inch ball ran on this part and left all this material here and all this material here, because you can see my part is very tight and I've got a lot of stock in that corner. And this is just, again, don't question the part. It's a simple part. Yes, I know vertical walls, this could be some 2D machine. I get it all. We're just looking at this conceptually. So that's my scenario. I'm here right now on the CNC machine, and now I got to decide, like, this is like a mold and die technique. You know, if this floor wasn't flat and this wasn't vertical, it's some organic shape, you know, this is hard to get all those corners, free flowing corners, cleaned out. So I'd like to kind of rough that out a little bit before I get to my finishing. So I know I've got this 1/2 inch, and the rad on the part is 1/8 inch. And I want to dig this out with a smaller tool in step ins, kind of. So I write this, I could write a pencil, right? I could write a giant pencil toolpath, but that's not ideal. It's going to bury the tool. What I really want to do is this. I want to write a pencil toolpath that digs in, digs in, digs in, and digs in. And if you see the stock, what happened was it machined it, boom, boom. So these tool paths here are pencil tool paths, all stepping in intelligently. Here, we'll go to that front view for you. And being very efficient and not cutting air, right? And to do that, what I did was, I did it with stock to leave and stock model reference. If I don't reference the stock model and I say leave 60th thou, I'm going to have all these, you know, all the passes would be all out here. So it does create all those out here, and it trims them and only keeps what was touching the stock model. So I said leave 60. And I said, look at this stock model, and I said, go. And it said, okay, those are the ones touching it if you were to leave 60,000 stock to leave. And then that's the result. That's your new stock model. I said again, leave 40, because I wanted to step in 20 thousandths of an inch. I left 60, now I leave 40. And I tell it, look at that stock model, number 3. So now it's looking at this stock model. And it says, these are the ones that touch it. And then I said, okay, update. And again, 20,000 step in, so I say leave 20. And then update. And then the final one, I just left 5,000 stock to leave because that's what I was roughing to, or 7. I left a couple thou extra, 7. Because this semi, this is 5,000 material heavy. There's $5,000 on this right now. And I semied this all the way down and I left 7. Why did I leave 7? Because this is a vertical wall and I wanted to stay away from it a couple grand and just not hit it. But again, don't, question the sample that we're using. It's the concept of digging in and digging in and digging in and digging in. So if I go into verify and we set up the stock model as our stock, and that's going to give us a nice visual of how this proceeds. I'm also going to keep the, I got the color coding on down here as well, and we'll find ourselves a good speed down here. Let's hit play. And there goes the pencil getting in. Turn our color loop. Digging in and digging in and digging in. It's going to go do the other side. All right. And then the next one and the next one and the next one. And then this one. And then that one. And nice and safe from the outside in. And then that part now has a nice consistent skin left on it. I left 7 here, there's 5 here. I could have went to 5 if I wanted to, and it's safe for semi-finishing now. And further finishing if I want. I can semi it again, or I can start to finish it now. So that's one way of digging into a corner. Okay. I call that pencil rest. Here's a completely different concept with a different toolpath. This is where it gets really fun. So I'm going to use equal scallop to create a toolpath that looks like this. It goes here, and then in, and in, and in. So the stock progression goes from here right? It's different, isn't it? It's kind of like it's shaving this whole surface in a different way. See, it's different than pencil, right? Where the pencil kind of did this thing where it's doing this L thing, right? L digs out an L, digs out an L, and then it digs out that L. So it's a little different in the way it progresses down, this notch. The scallop is different, right? Like that, like that, like that, and like that. Now this one takes a little more work. So this is pretty wild. Here's what happened here. Let me grab my levels. I have a mesh. This is a mesh of that stock model that I semied. This is the same stock model I used to start the pencil. It's a mesh model. It's basically, it's this stock model up here, the guy that we were, this is our stock model. I can't touch or select this, it's nothing, but we can right click on it. We can convert it to a mesh, triangle mesh. That's what I did. So we'll go back to my levels. I'm going to turn that on with my part, right? Turn the stock model off. So I've got this mesh sitting here. In this toolpath, what I said was, on this page, I said, I want to machine the mesh, the stock model mesh. That's my drive data, the mesh. I want to I basically created that stock model as a mesh because I want to cut it. And for the first cut, I said, I want to go -20 into it. So I want to step 20 into that. Over here, I said, I want to avoid something. I want to avoid. And to avoid, I picked the solid model, my solid, right? Now, this drive data that I select, this mesh is 5 thousandths heavy. Now, I said dig in 20. But my stock model, my stock solid, my part is under there. And I'm saying, but stay 5 away from it. So when it goes -20 here, all right, remember there's only 5 thickness. When it tries to go -20 in this area, it winds up hitting the avoidance and it stays away from it by 5. But here, where that stock is heavy, right, it can dig in 20, and it does. And that's how you do this. That's how you do this. So basically, you pick your model to avoid, you pick the mesh of this stock and you say, I want to carve into it. And this is pretty easy to put together because the drive check never changed. All you're changing now is negative. So I went -20, -40, -60, -80, and eventually I'm done. And this is equal scallop, and it creates beautiful, beautiful, smooth motion. Beautiful, smooth motion. And it's just different stock, negative stock, negative stock, negative stock. And if you want to take a look at that one in here, it digs in a very different way. There it goes. And then at that one, nice, clean, no heavy cutting. Again here, no heavy cutting. And then again, and then again, and so on and so on and so on until I get to my final clean shape that I feel comfortable continuing on with my finishing processes. And that's rest scallop. And then this one here, like any other example, I couldn't help it, but I'd like to show that I could also, because this is a vertical wall, if this was a real condition you were concerned about and you didn't relieve your tool, there's no relief on the wall, don't forget we have tilt, right? I just turn on the tilt and now I got a multi-axis method to dig out these corners. Slow it down, right? Here it is, going around, nice and graceful, avoids that problem, boom, comes around and avoids it really nice. So, you know, it's all fair game. It's all fair game. These are just multi-axis versions of these. So the reason that you kind of want to dig these big corners out at times is because you're just trying to make your finishing, you know, safe. You know, and here's some of the finishing routines that I might have been trying to accomplish. Like maybe I wanted to just run the 1/8 inch on the whole part. I'm not saying you would, but I was able to clean this corner after the 1/2 inch, rip this 1/8 inch on the whole part if that's what I wanted to do. You know, maybe what I wanted to do was turn those vectors off. Was finish this whole part to 0, but not go into these corners and then clean these corners with pencil rest and do a final pencil finish. So I use stock engagement like we just talked about. I wrote a water line and a raster, and you can see them staying away from my stock. That was max stock engagement. And I wrote this 0 stock to leave toolpath. So it just left material here, 0 stock to leave. I turned on max stock engagement like the last example on this page. So I was able to rip the water line. I let it dig into the stock 20 grand, but I was machining to 0. So that part is basically, you know, kind of finished on the walls, and everywhere else the corner's heavy. So then you dig the corner out down to 5, you leave 5 thou on the part, whatever, and then you run a pencil to final 0 stock to leave, right? But this pencil is not very efficient. Look at all this overcutting. It's the nature of the pencil finish. It just does a number of offsets left and right. Depending on steepness, it can overcut. So we clean it up by referencing a stock model to trim to. And I pointed it to my clean stock model that had the semi-ran on it. And then it goes from this crap here, all the overcutting, to this, right? This was the max stock engagement model. You can see from the front, 0 stock to leave, 0 stock to leave. There's the material after my corner machining, and then I can run these pencil rests to clean that if I wanted. So I took this model, I carved these two finishes into it. That leaves me with this shape that I can then run this pencil. I don't want to run this pencil, it's a lot of overcutting. I ran this pencil and trimmed it to this shape. So this is using all the concepts together. I'm using max stock and engagement. I'm using from the first examples where we isolated the pencil or we trimmed to stock with that pencil and waterline. I'm using max stock engagement. That's what lets me run this toolpath safely with that small tool. And then I'm using these corner concepts to be able to clean out areas. I could use the pencil or the equal scallop mode. And then to finish, again, I can just rip a toolpath across the whole thing if I wanted to, like this. Or if I did the max stock engagement to 0, I can do a pencil. And I used stock trim to get from this to this, right? There are other ways. I could run the full-on hybrid with, this is a finish hybrid, and I can run, again, pencil cleanup. So it's just, the name of the game is, it's always about managing stock and the condition your tool is in. And being able to lace motion where you want. So hopefully all these concepts you saw today give you some additional tools to be able to put motion where you want and to be able to control your safe cutting conditions when you're getting into tight areas and smaller tools and such. Or if you want to be aggressive and rip a 1/2-inch end mill over something and then go in with some small eighth or quarter or some smaller tool and just do some nibbling. Sometimes it's simpler that way. So I hope all this helps. And these were, again, concepts of introducing stock shapes to finished toolpaths and semi-finished toolpaths. So we've got some time for questions if there are any questions. Otherwise, I appreciate everybody's time.